Transport with pitfalls. An almost 50-meter-long rotor blade has to be transported up a hill.
The difficulty is definitely the rain. The road's wet, there's not much traction.
A real obstacle course. Tight hairpin corners. Houses directly at the edge of the road. Rain-filled tracks.
In the worst case, the road would give and then we can't continue the journey.
A gigantic unit is on the move. 442 tons and a length of 75 meters. And mishaps despite perfect planning.
One of the hoses has burst on the trailer.
Precision work in the underpass. Tight at the top, critical at the bottom.
I need more height here. It's already scraping.
And heavy-duty equipment for 195 tons. High-precision loading into the barge. A range of hills in the Black Forest. 4 wind turbines, each around 200 meters high, are being constructed here at Kambacher Eck. They're intended to produce electricity for 10,000 households. One of the problems of constructing them is transporting the materials. The road on the hill is steep and winding. It passes through small settlements and is only partially asphalted, hazardous, especially in bad weather. 400 meters lower down in Kinzig Valley, a transfer station, the starting point for the heavy loads. This is where the construction elements are stored, from the concrete shells to the gigantic rotor blades. These are 46 meters long and each weigh around 15 tons. Today, one of these blades has to be transported to the top of the hill for assembly. Even loading it onto a transporter is a tricky process.
Too much wind is dangerous, of course. We have regulations that we have to stick to. But at the moment, everything's okay. If there's too much wind, we'd have to abort.
The 72 studs at the end of the rotor blade now have to be inserted into the holes on a transport device. This is really delicate work when using a crane, because the studs cannot be damaged under any circumstances. The rotor blade has to be raised slowly so that it doesn't swing away abruptly.
Both cranes raise cable.
Loading manager Mario Horvath issues commands to the crane operators by radio.
Height's good, you can slow it out.
After just 2 minutes, the rotor blade is suspended in the loading position. But it can't be loaded yet. First, the square transport frame used to transport the blade by truck to the transfer station has to be removed.
Good, stop.
Mario Horvath uses a wheel loader to raise the transport frame and unscrews the enormous nuts from the threaded rods together with a colleague. Then the frame has to be removed from the studs.
Shall we give it a go now?
But the frame is catching.
Wait, I'll have to back up.
So he climbs back into the wheel loader, backs up 1 meter, and raises the loader's arms a few centimeters. Then the studs are free. Loading can begin. Transport manager Randolph Peters from Spedition Benda has arrived. He's a specialist in operating the transport vehicle, called a self-propelled modular transporter. It can be steered by radio remote control. A rotor blade transport device is mounted at the end of the 8-axis vehicle. The men now have to fasten the rotor blade to it. Threading the blade studs into the holes requires finesse from Randolph Peters and the crane operators.
Roman, let the cable out. Stop. More slowly, let the cable out. Stop. The most difficult thing is actually inserting the threaded rods into the adapter holes. Then it's bolted, tightened with a torque wrench, and then we're done.
While the studs slot into the holes on the transport device, something is still catching. Randolph Peters has his own special technique for this.
We shake the adapter so that the threaded rods of the rotor blade can be inserted more easily into the adapter. Mario, the front crane needs to slew a bit to the left.
Thomas, slew slowly to the left. It looks relatively parallel from the top.
Tighten one of the bolts, a sleeve.
I can't yet. We need to move closer, but we're still too high.
Wait a minute, that fits. I'll tighten it.
In.
Perfect, isn't it? Good.
Mario Horvath and his colleagues now bolt the rotor blade to the adapter. Pretty strenuous work with 72 nuts. The rotor blade is only ready to be transported up the hill with the self-propelled transporter once all of them have been properly tightened. The gradients are up to 20%. Lots of power is needed to make the climb.
So here we've joined two 4-axle platforms together. The front 4, the rear 4. Each 4-axle platform consists of 4 axles, each with 8 wheels. So in this case, we have 64 wheels here. The engine is separate. It's a 500 horsepower Deutz, a 6-cylinder. It drives a hydraulic pump, and the drive hydraulics are connected to the drive axles with hoses.
And that's a total of 4. The hydraulic system also produces more torque than a mechanical drive using a propeller shaft, for example.
It's like a water wheel. If you pour a lot of water on it, it turns faster. If you pour less, it turns slower. If you pour in the opposite direction, the wheel turns that way, and that gives us the hydraulic braking effect here.
Each axle can be steered individually, around 360 degrees. And the swing axles are able to compensate unevenness in the carriageway so that the self-propelled transporter doesn't start to tilt, unless the wind continues to pick up.
Things get difficult over a wind speed of 12 meters per second. Then, that's it. Then there's a safety program that shuts off the electronics. That's measured over the wind gauge that we're just fastening at the front here. Over 12 meters per second, we're no longer allowed to work.
There's a 50-50 chance that the transport will proceed smoothly, because the sky has clouded over and it's pouring with rain. A bad omen for the complicated project.
The difficulty is definitely the rain. The road's wet, there's not much traction. We'll just have to take a bit more care than usual. And I hope that the wind doesn't pick up even more. Otherwise, let's hope that the weather doesn't get any worse and even colder. If it starts to snow further up, we'll have to stop. With snow in the road and an 18% gradient, then we can't continue due to safety reasons. There's no more traction.
The 500 horsepower self-propelled transporter starts to move. With his remote control, Randolph Peters can not only steer and accelerate, he can also turn the rotor blade up by 60 degrees and rotate it around its own axis. Philip Backhofen is the advance party. The 25-year-old provides the transport driver with instructions.
A bit more to the right. You've got room on the right now.
Then the first obstacle appears. Not the house at the edge of the road, but several power lines in a right-left corner combination, in which a utility pole is also located. Careful maneuvering is now required.
Right, here we have to raise the blades and drive forwards up to the power line. Then we have to move the blade over the power line and back up until we can lower the blade ahead of the power line. Because we could get the vehicle round the right-hand curve in terms of the radius, but the blade's too long to get past the utility pole.
Randolph Peters now drives as far as possible into the right-hand curve without touching the power line with the rotor blade. Then he backs up into a junction that goes uphill. The hydraulic system compensates the dip and the gradient. The center axles are first extended downwards, and then the front ones.
You can lower it slowly now. Continue lowering it. Right, that's enough.
The blade is only lowered enough so that it just passes beneath the power line.
2 meters to the pole. 1 meter.
The first power line is followed directly by a second one in a left-hand curve. The rotor blade again has to go over it.
Raise the blade a bit more. Continue raising it slowly. 2 meters to the cable. That's good.
Once again, the transporter moves as close as possible to the line. Then it has to carefully maneuver once more.
We're now backing up a little so that we're positioned straight in the curve, so that we're parallel with the cable and can then lower the blade under the cable. So lower it slowly. No, lower it a bit more. But you don't need to back up again. That fits. Good.
The first difficult obstacle has been overcome. But that was nothing compared to what's up ahead. Renk AG in Rheine in the Münsterland region. It's all hands on deck today in one of the large hangars at the gear unit manufacturer. A drill head gear unit costing around 2 million euros is scheduled to be delivered to the customer. A real challenge for all involved.
We'll leave here at around 10 p.m. with special truck equipment and head off to Speller Port in Speller Venhouse. The gear unit will be loaded into a barge. From there, it's off to Rotterdam, where it will be transferred to an ocean-going vessel. Finally, it will be taken to our customer, a Belgian-Luxembourgian dredging vessel specialist at the shipyard in Croatia, where the most powerful dredger in the world is being built.
Problem number 1. The gear unit, which weighs 195 tons, has to be moved from its assembly station to the loading station behind the special truck. But the cranes can only carry a maximum of 120 tons.
So we had to find another way to move the gear unit from this test area to our loading position over there. We're using a skidway that enables us to pull these carriers that run in this rail on Teflon using hydraulic tensile forces. And then we can move it over this section from over there to the loading position.
So that everything runs smoothly, soft soap is brushed onto the Teflon plates. With an oil pressure of 80 bar, 2 hydraulic cylinders push the gear unit to the loading points centimeter by centimeter. Problem number 2. The gear unit can't be transported with a normal low-bed trailer. It's simply too high.
We have to transport this gear unit from Renk with an overall height of 4 meters 95. And we use this tank bridge to do that because it enables us to transport the gear unit with a ground clearance of 1 centimeter through our bottleneck. That's the underpass beneath the A30 freeway.
The outer sections, the so-called Z-members of the tank bridge, are mounted on 2 14-axle trailers, only one of which is already in the hangar. The outer sections are connected using intermediate pieces, 2 steel beams with support brackets, each weighing 6 tons. The gear unit, which has now reached its loading position, is placed onto these later on. The longitudinal members are now positioned on both sides. This process is managed by Matthias Kirschner, who everyone simply calls Mattis.
Let it down, right, now down.
Both beams are in position and now have to be connected to the outer sections of the tank bridge.
Okay, back up then. Further, further. Further, another 2 meters. The trailer needs to move to the left a bit at the front. Stop. Okay, give it a try.
On one side, the connecting pin fits almost immediately.
Good, good, good.
On the other side, however, it's still catching.
The problem at the minute is that the pin lug coupling isn't aligned properly yet. Now we can move the bridge slightly here at the top, and we want to move the side in a bit. And then it should fit. We've still got some space here, and now we have to move the beam out a little so that the coupling can mesh better here.
That's not as simple as it sounds. For 40 minutes, everything that can be adjusted is readjusted. Then finally, the second side slots into place.
So we'll get it in now, normally. Good, Ingo. It's good. It's in.
But that was only half of the job. The tank bridge now has to be assembled on the other side as well. The second part of the transporter moves to the hangar door. And unlike the delays beforehand, everything now goes like clockwork.
Slowly. Further. Further. Stop. Good, good, good. Get it in. Fitted right away. At the back it was too tight, you know, but now we'll attach a few chains and off we go. Done.
Well, we had a few difficulties here on this side while we were assembling the tank bridge because the beams were slightly skewed. The whole process took a while, but ultimately the job was done quickly. And when we've secured the load using anti-slip mats here at the transfer points, we'll take over the load with the tank bridge.
Tank bridge is raised and now bears the load, the 195-ton gear unit. The men from the transport company additionally secure the load with tensioning chains. Then the transporter leaves the building. Things are now really tight at the hangar door.
Back up a bit.
Yeah, come back in.
It was a bolt head, not much.
Come on, keep coming in.
Should be okay now, Matthias.
Okay.
Success! The transporter passed through the tight spot on the second attempt. First, it moves to the parking position, because there are another 5 hours to go before the hauling process starts. Suddenly, there's panic.
Come here, something's wrong, quick. The other side.
Everyone is running. Oil has leaked somewhere. Everyone hopes that the journey isn't in jeopardy now. In the Black Forest, the rotor blade has been transported over the first flat section. Now there's a 400-meter ascent to overcome.
From here, we'll drive backwards the rest of the way because that's the easiest way to manage the route. The tight curves are easier to manage with the blades if we reverse. So we're going to turn here, move the blades up over the cable, and then back up the rest of the way.
The turning maneuver with the self-propelled transporter proceeds without a hitch. After reversing for 500 meters in open terrain, they enter the forest.
We're guiding the rotor blade through a 2-meter wide path that we cut beforehand.
Carry on, everything's okay.
It was mainly branches that were in the way. Only 6 trees had to be removed completely.
Starting here, we have to turn the rotor blade a lot to adapt to the route layout.
Maximum concentration and constant coordination between the driver and spotter are needed to maneuver the rotor blade through the treetops without catching or damaging it.
Slowly. Now we're moving into the tree. Raise the suspension a bit at the front.
We're coming to the area where there's a gradient of up to 20%. Walking backwards uphill is more strenuous for me than for the SPMT. With this weather and the wet road surface, we have to make sure that we can continue without losing traction.
Keeping an eye on the edges of the road on both sides, steering, accelerating, making sure that the rotor blade doesn't catch anywhere, raising, lowering, and rotating the blade as required, multitasking, while walking backwards.
At some point, your body gets used to it and you develop muscles for walking backwards. And then it doesn't hurt quite so much. It was hard at first, but you get used to it in time.
The next tight spot for the transporter is a sharp S-curve with a gradient of 16%. For it to work, several things had to be changed here.
The road was asphalted because it was already damaged beforehand and it wouldn't have survived this transport. And the curve radius was extended a bit by around 2 meters. But otherwise, the curve runs like it was originally built 100 years ago.
Back then, though, no equipment with a length of 50 meters, a width of 3 meters, and a weight of 85 tons had to pass through here.
The blade has to be set completely upright at 60 degrees to slew it through the trees here. And it gets increasingly steeper. So it's going to be more interesting than the first uphill section. We have to make sure we don't hit the tree so the rotor blade isn't damaged. That's the challenge from here on. Philip?
Yeah? Yes?
Okay, off we go.
Okay.
Randolph Peters slowly sets the remotely controlled, self-propelled transporter in motion. Too much acceleration, and the wheels would spin when moving uphill in wet conditions. After all, the transporter has 500 horsepower, and with a gross weight of 85 tons, it needs all of them. All of the 8 axles can be steered individually. Despite this maneuverability, the road isn't wide enough for the transporter. It gets into the gravel bed. At the top of the rotor blade, things are now also getting tight.
Mach mal langsam.
Slowly now and keep coming straight. Everything's fine up here, keep going.
Done. They've made it through the most hazardous curve. The rotor blade transporter has now completed almost 2/3 of its 400-meter ascent to Kambacher Eck. But on a difficulty scale of 1 to 10, the Serpentines only scored a 7. The 10 is coming up now.
So after walking backwards for 4 kilometers, we've now reached Wenglik. Once again, we have to pass through the houses where we have to rotate the blade between the balcony and beneath the power cables. And then comes the steepest stretch with a gradient of 19%. We have to make sure that we tilt the self-propelled transporter laterally a bit to get past the balcony. It's very complicated. You have to watch exactly what you're doing. You should think through it beforehand. There's 10 to 15 centimeters of space everywhere. It's enough, but we have to be careful.
To pass the first house, Randolph Peters has to lower the blade. But he can only do that after the curve because otherwise the trees will still be in the way.
2 Meter bis zum Baum, immer weiter.
2 meters to the tree. Keep going. Everything okay. Go slowly. Now go straight. Great. That's good.
The rotor blade is now lowered. At a snail's pace, it moves past the house and beneath the power line at the same time. Break time. One of the residents, Thomas Heitzmann, has made coffee for the men from the transport company.
What does the transporter cost?
1.2.
1.2 million. And you mainly transport blades or other things as well?
We transport machines, but mainly blades.
How many metric tons can that thing carry?
40 tons per axle. And you can assemble it depending on how many axles you have. Over 20 axles and you need a second engine.
How much longer will it take to get to the wind turbines?
We're going to the first one now. That's a bit further than the third or fourth. I think it'll take us about another 2 hours. It's relatively slow going through the forest, but 2 hours should normally be enough.
I'm a big fan of these wind turbines because we have to stop using nuclear power. Otherwise, all of the generations that come after us will have a problem with the waste, and nobody knows where to put it.
Thomas Heitzmann has had to move his garden wall 1.5 meters to the right and remove a garden fence on the left for the transport deliveries to the wind farm. It was a price he was happy to pay to stop using nuclear power. And he's also willing to put up with the transport noise.
I work in road construction and it doesn't bother me. It's interesting to see the whole procedure. Often it's precision work. It's worse at the weekend with all the rubberneckers who drive up here. Their vehicles are more of a disturbance than the big transporters. I'm not afraid for the house, because they drive their machines so well.
The work continues after a 15-minute coffee break. Now comes the most difficult phase of the transport. Philipp Backhofen returns to his position so that he can give Randolph Peters instructions.
We're going to back up here until we're past the cable so that we can raise the blade and slant it to get past the jutting part of the house. And then we can cover the rest of the route, the gradient, with the rotor blade raised.
That sounds simple, but it's going to be complicated. A gigantic transporter is leaving the hangar at the Renk plant in Rheine, North Rhine-Westphalia. It has 36 axles, is 75 meters long, and weighs 442 tons. On a tank bridge, a steel construction that can be raised and lowered, it's transporting a drill head gear unit for a dredging vessel. With a weight of 195 tons and a price tag of around 2 million euros. Today's transport is destined for an inland port located 12 kilometers away. One of the hauling company's employees suddenly sounds the alarm.
Come here, something's wrong. Quick, the other side.
Oil has leaked from one of the trailers. The hydraulic compressor now has to be shut off immediately. The heavy hauling company employees scatter binding agent.
One of the hoses has burst on the trailer.
These things happen, it's out of our control.
Manfred Mewes, the team's boss, also helps with the cleanup.
As the transport manager, you're not an idle bystander. You're part of the process. And when sweeping and scooping up are needed, you help out. During that time, our colleagues can deal with the technical side. I don't have much of a clue about that. I then help out here.
Technical expert Matthias Kirschner is attempting to find the problem. After 10 minutes, he's discovered the leak and removed the defective hose.
Over time, they become porous, and then the sheathing, the rubber cracks. And then the wire in between rusts, and this happens, despite the fact that you have to replace them every 6 years.
Because that happens from time to time, the men always have enough replacement parts with them.
The transport isn't in jeopardy. Unfortunately, these things happen. Of course, it shouldn't happen just when we're leaving the building. Matthias will quickly fix it, exchange the burst hose, and then we'll continue heading out.
After half an hour, the damage is repaired, and the transporter moves to its parking position on the plant premises. It's only allowed on public roads after 10 p.m. Otherwise, it would cause traffic chaos.
We've now reached our temporary parking position. Temporary means that we'll complete a few remaining jobs, and then I hope that we can set off for the port on time at 10 p.m. It's annoying that the reinforcement hose burst. Fortunately, it happened here at the start of the process when we're not yet on the road, where we might have caused major traffic obstructions for half an hour. So, I think that if it has to happen, then preferably here and now.
While the men from the heavy hauling company now have a 4-hour break, final preparations for the gigantic transport convoy's passage are underway in the town of Rheine. A traffic light on a traffic island is in the way. Employees from a traffic technology company have arrived.
The cables are connected down here so we can remove the pole. It's then provisionally placed to the side.
Once the transporter has passed, the traffic light can be placed back on the traffic island on a provisional base. At some point over the next few days, the traffic light will then be fitted with a bracket so that it can simply be pulled out when the next transport journey takes place. But first, the old foundation hole has to be filled in again.
Where we've removed the pole, we've now replaced it with a base plate like this, where the warning boards go. Because I don't know exactly where the truck will go with its wheels. This is to make sure that firstly it doesn't sink in, and secondly it doesn't ruin its wheels on the old bolts that are in there if it sinks in. Then it will get stuck right here. It won't get very far then.
The soil is pounded down firmly a couple of times, and then everything is ready for the heavy haul vehicle. In the Black Forest, Randolph Peters and his transport crew are facing a delicate task. The 46-meter-long rotor blade for a wind turbine has to pass through the community of Wenglig. That would be a relatively simple matter in a horizontal position, but the transporter would then be unable to make it around the next left-hand corner without touching the last house.
We're now raising the rotor blade to get it vertically between these two edges of the shed roof and the house roof.
But first, the blade has to clear a power cable. Philip Bachhofen has taken up his position behind the remote-controlled self-propelled transporter to provide assistance.
Tell me when I'm past the cable, okay?
Great, that's good. Further.
I must be past the cable.
I can't understand anything.
Cable.
Cable is passed. We're past the cable. You can raise it.
Randolph Peters raises the rotor blade up 60 degrees hydraulically and rotates it around its own axis so that it's as narrow as possible. What could now prove hazardous are gusts of wind. To get past the house roof, the self-propelled transporter has to travel as near as possible to the wall on the right-hand side without coming into contact with anything. Now things are also tight at the edge of the roof. Randolph Peters tilts the self-propelled transporter as far as possible to the right, but there's still only a few centimeters of space to the roof gutter. The masterpiece of maneuvering is completed. To make it around the following left-hand curve as well, the rotor blade now has to be slewed over the house roof.
We've completed the steepest section now. All of the gradients went really well, despite the fact that it's raining and relatively cold, but no traction problems. Now we're coming to the area where there's no more asphalt, it's all graveled. I hope the rain hasn't made it too soft and that we get through it here without any problems. In the worst case, the road would give way and then we can't continue the journey. But at the moment, everything's looking good.
Randolph Peters has no idea that the rain further up, where the wind turbine is being built, has already turned to snow. The rotor blade transporter still has to cover around 2 kilometers on a gravel road that's becoming muddier by the minute. The 43-year-old attempts to bypass the worst parts to avoid getting stuck. He can operate the remote control blindfolded, or rather the 2 remote controls. One with which he can accelerate, brake, steer, and tilt the self-propelled transporter to the side and longitudinally. And in front of that, another remote control for the transport device, which he uses to raise and lower the blade and to rotate it around its own axis. Compared to this, a PlayStation is nothing but a child's toy.
I think you have to have a basic feel for it, otherwise you can't do it. It's like the hydraulics on a low loader. You also have to operate that sensitively. And that's also what it's like with the joystick. But here you also have the delay caused by the radio remote control. Of course, it becomes easier with each transport journey because you learn and become more foresighted. But there's probably always a learning process because there's different weather every day. Wind. You're always learning.
A 400-meter ascent and numerous obstacles have been overcome. The transporter reaches its destination, the construction site, at Kambacher Eck. The transport crew has completed a 7-kilometer march uphill in the wind, pouring rain, snow, and icy temperatures.
The weather's miserable. We've been lucky. If it had started to snow an hour earlier, we would have had to abort. But we've arrived in good time. It's been touch and go, but everything went okay. Time to call it a day.
In Rheine, North Rhine-Westphalia, the stress is just starting. The 75-meter-long transport convoy with the 195-ton drill head gear unit is setting off for the inland port of Spelle-Venhaus. It's only a distance of 12 kilometers, but there are quite a few obstacles to contend with. The first tight spot crops up just after 300 meters.
Watch the traffic light up there. The problem at this intersection is that we can't turn directly to the right towards Osnabrücker Straße. Instead, we first have to drive straight ahead and then back up into Renk's main entrance. The curve radius is then better for us to continue driving to Osnabrücker Straße.
Backing up into the plant entrance proves to be relatively simple.
Stop.
Driving out around the curve proves to be tighter, though. There's a problem at the rear with a road sign.
The sign's buried in the gravel.
You cut it off at the top.
We have a small obstacle here, this sign. It stood where we would swing further out with the tank bridge beam if we continue driving around the curve. So Mr. Schulze is now coming to temporarily move the sign to the side.
Mr. Schulze is Ralf Schulze, who drives ahead of the transporter with the men from his traffic technology company and moves obstacles out of the way. He now rushes back to the transporter. The question is whether he actually has to cut the sign off.
I don't know yet. We'll see. It was a bit tight. Now they're having another go. Maybe they'll manage it.
Back, right?
Yes, back.
Well, looks like it's working now. Go.
Go on, we're past it.
The transporter moves through the tight curve. One advantage is that the two 14-axle trailers can be steered separately from a cab or by remote control. A 600-horsepower tractor unit is now coupled at the front to cover the rest of the transport route.
We've unhitched the rear machine from the trailer and are now coupling the one at the front, because when the rear one pushes, it tends to lift up and push over the front axle. And that's why it's more sensible to couple it at the front, which is what we're doing now.
The next few kilometers mainly involve passing beneath low-hanging traffic lights. The tank bridge is lowered each time to do this, or turning off at intersections at which the 75-meter-long transporter has to avoid several traffic signs and street lamps. Driving over traffic islands doesn't pose any problem whatsoever.
When we're driving over this island, you can clearly see how the swing axle functions. The cargo bed constantly remains level and the axles beneath compensate uneven areas in the roadway. When the axle rolls up over a curb, over there, for example.
Manfred, your car.
Excuse me.
The transport manager's support vehicle, from which he warns the truck drivers about upcoming obstacles, was almost run over.
In a minute, we're turning off to the right, from outer left to inner right.
Yep.
We're now coming up to the most interesting point of today's journey. That's the underpass beneath the A30, which we're going to drive through on the left-hand side, because that's where the construction offers us the most clearance height. And we'll lower the cargo almost to the ground, which will then give us just a few centimeters above it at the exit from the bridge.
But the first problem isn't the low concrete elements.
They've all got to move.
Bystanders have parked precisely in the path of the heavy haul vehicle.
Whose is this car? Request to the police, can you please use your loudspeaker to get the driver of this car here on the left to return to his vehicle?
After 5 minutes, each parking violator has been tracked down.
Okay, he's here.
The transporter's passage can begin. A dead slow speed is needed. The tank bridge is lowered before reaching the first concrete beam. There is now a gap of only 1 centimeter between the transport frame and the asphalt.
We've now passed beneath the first concrete beam. It's going well so far, but the bridge is lowest at the exit at the last concrete beam. So we've purposely positioned the boom lift there so that we have enough light and can see things clearly.
On the boom lift, Ralf Schulze's job is to warn the team by radio if it's too tight at the top.
We're now approaching the crucial concrete beam. Ralph, can you see clearly?
I can see everything.
Things first become tight at the bottom. The heavy haul vehicle seems as if it's about to slice off the asphalt.
I need a bit more height here, it's already scraping. If we make contact at the bottom, theoretically we could drag it over the road with the engine power that we have. But we don't want to do that. We only want to pass through with the smallest ground clearance to give us the biggest possible gap at the top.
The last concrete beam, the lowest one.
We've got a good 5 centimeters up here.
We were expecting 4.
Gear unit's almost through. We now have 40 to 50 centimeters of space at the top.
So we can now move to the right towards the center of the road. Perfect. Relief. You bet. We all saw that there wasn't much room up there. It was confirmed that we had 5 centimeters. We were pretty much gliding over the asphalt at the bottom. So yes, it's great that it went well.
Ralf Schulze now has to get a move on because he has to provide assistance again at the next critical point along the route. A bridge over the Dortmund-Ems Canal that the transporter is due to reach in a few minutes.
The statics of this bridge have been recalculated, and we've been given specific instructions for it. They state that we have to cross in the center of the bridge. That's not unusual, but the center of the bridge isn't the center of the road. Otherwise, it would be relatively easy for us to position ourselves there. And that's why Ralf Schulze is going to place traffic cones 2 meters 40 away from the right-hand guardrail. We'll drive past these with the right side of the vehicle, and if we don't drive in the center of the bridge, we'd almost certainly damage the structure.
2 meters 40 from the edge of the road, painstakingly measured. A transport company employee suddenly appears. The traffic cones have to be repositioned. There seems to have been a communication problem.
I understood left-hand side during the meeting beforehand, but that was wrong. It's got to be measured on the right-hand side. That's why we've changed it quickly.
Quickly was more than necessary because the heavy haul vehicle is already approaching. As it crosses the bridge, an employee collects the traffic cones again. Now it's less than 2 kilometers to the final destination.
When we're on the road to the port in a minute, it would be good if we could stick to the right because there were already a few cracks in the roadway on the left.
And we've got the preservation of evidence procedure again tomorrow, and I don't really want to make the condition any worse.
There are warning boards on the right.
That's fine, Matthias. Everybody makes an effort to make sure that we don't break anything, that we don't come into contact anywhere. And ultimately, that's a good calling card for the customer if we've put in a good performance.
The entrance to the inland port in Spelle-Veenhaus. The transporter has taken 3.5 hours to cover a distance of 12 kilometers.
I've just said it again back there, a super performance.
The men can now enjoy a break for a few hours before the next feat of strength. 10 a.m. the following morning. The barge that will transport the drill head gear unit to Rotterdam is just mooring. Two 500-ton mobile cranes are needed to transfer the load from the tank bridge into the vessel, although the gear unit only weighs around 200 tons.
Two
500-ton cranes. You're probably asking why we need them for a gear unit that weighs 195 tons. That's because a 500-ton crane's lifting power is at its minimum reach. But the task here involves a distance of 40 meters 60 to the barge. And that means we only have a lifting power of 100 tons. And that's not enough for this 195-ton gear unit. So we need two cranes.
The danger when working with two cranes is that they could get in each other's way.
We're
going to lift the gear unit out of the tank bridge now. When we've reached a certain height so that we can get over the beams, we'll have to slew the gear unit at an angle of 90 degrees. The reason being that otherwise, if we were to slew towards us now in this position, our pulley heads would come into contact, that is, they would collide. So we'll slew it out at an angle of 90 degrees over to the barge. There we'll slew it back again 90 degrees and set it down in the hold.
But first, the crane operators have to lift the gear unit absolutely vertically out of the transport fixture. It's critical that the freight doesn't start to swing.
That would lead to a sudden movement in the crane that might be difficult to get under control, so to avoid that, we simply lift it smoothly upwards.
An almost perfect success. The gear unit is only swinging slightly. The transporter with the tank bridge drives off. It would only be in the way during the maneuver that's now coming up, which is to slew the gear unit between the cranes to the vessel. The drill head gear unit is now lowered into the vessel's cargo hold. Once again, precision work is required here.
The difficulty now is that we have to position the gear unit centrally in the vessel, simply so that the barge doesn't begin to list. That might not even be noticed here directly at the wall, but when it casts off, the vessel might start to list dangerously. That's why we have to make absolutely certain that we put it down centrally in the vessel.
Touchdown. The gear unit is put down in the cargo hold. The crane operators relieve the load on the cables, and the vessel sinks down almost 1 meter. Although the load isn't precisely in the center, it's okay for the captain.
It's okay.
The men from the heavy hauling company have completed their job.
We had a minor setback, a burst reinforcement hose, fortunately at the company's premises and not on the public road. It was quickly rectified, and then everything proceeded smoothly. Loading by crane, the cooperation between the two mobile cranes here was perfect too. So all in all, the transport went very well.
12 kilometers have been successfully overcome. There are another couple of thousand to go by sea to the final destination in Croatia.